So now I'm going to take a look at the second half of 414's review, but now I'm going to do the polar questions. All of these are without a calculator, so I'm going to talk through how I got my answers. So 300 degrees is in quadrant 4. It's a 60-degree reference angle. Remember, all students take calculus tells you where each of the functions is positive in sign, S-I-G-N. So they're all positive in quadrant 1. Only sine is positive in quadrant 2, tangent's positive in quadrant 3, and cosine is positive in quadrant 4. So sine is going to be negative, and I know that the sine of 60 is root 3 over 2. So my answer is negative root 3 over 2. The cosine of negative 120, so that puts me over here. Again, it's a 60-degree reference angle to the nearest x-axis. Cosine is negative in that quadrant, and I know that the cosine of 60 is 1/2, so my answer would be negative 1/2. The sine of negative 270, so that puts me all the way up here on the positive y-axis at the coordinate 0, 1. And remember, x, y corresponds to the cosine and sine values respectively. So the sine value is the y value at that point, which is 1. So that makes the sine 1. 315 is down here in quadrant 4 again with a 45-degree reference angle. Cosine is positive in quadrant 4, and the cosine of 45 is root 2 over 2. Pi over 3 is in quadrant 1. It's a 60-degree angle in radians, and I know the sine of 60 is root 3 over 2. So positive root 3 over 2 is the solution. 15 pi over 3 is the same as 5 pi if I reduced that. So if you count going around the circle, 2 pi is once, 4 pi is second, 5 pi would put me over here on the negative x-axis where the cosine value is the x value of negative 1. Cosine, negative 7 pi over 6, so that is just past pi, 30-degree reference angle. Cosine's negative in this quadrant. Cosine of 30 is root 3 over 2, so my solution is negative root 3 over 2. 11 pi over 4 is really 8 pi over 4 plus an additional 3 pi over 4. 8 pi over 4 is once around the circle because it's 2 pi. So I'm really just asking you what is the sine of 3 pi over 4. Sine is positive in this quadrant, and the sine of, this is a 45-degree reference angle, the sine of 45 is root 2 over 2. So the answer is positive root 2 over 2. So if you need to study that, that is what would be on the quiz, the trig quiz on Thursday. So those types of conversions and relationships between the ratios. All right, so plotting coordinates. So if I'm at an R value and an angle, right? So R value of 2, angle of 180. So I go over to 180 and just count 2 units out. So there's point A. An R value that's negative, the first thing you do is you go to that angle in question. So here's, this must be 30 right here. So if I continue that through to make a straight line, instead of going 30 degrees, 3, I'm going to go the opposite direction, 1, 2, 3. So here would be point B. And 4, 150, so if this is 180, 150 would be here. And I'm going 1, 2, 3, 4 units in that direction. So there's point C. So converting between polar and rectangular and vice versa. So if you're already in polar, you want to think about if you're a quadrantal angle. So this is actually a quadrantal angle because it's a 3 pi over 2. I'm going to do this one first. So if I'm at 3 pi over 2, I'd be down here. And then it says go 2 in the opposite direction. So I'm actually going to be up here. That's easy to write with x's and y's because it's 2 units away from the origin. So it's just the point 0, 2 in rectangular form. So the formula to get your x coordinate is r times the cosine of your angle, and to get the y coordinate, it's r times the sine of your angle. So I'm going to do 5 times the cosine of 150 and 5 times the sine of 150 to get my solution. So I have to think again, cosine of 150, these are 30-degree reference angles, right? So I know the cosine of 30 is root 3 over 2, and cosine is negative where 150 is. So this would be 5 times negative root 3 over 2. And this one's positive in quadrant 2, so this is just 5 times 1/2. So my final answer would just be negative 5 root 3 over 2, comma, positive 5/2. So that's the answer for part A. That's the answer for part B. Now I'm going from rectangular into polar form. So I'm using Pythagorean theorem and tan inverse. But if it's a quadrantal angle, like -7, 0 for my x and y values, I can think of that I'm 7 units away from the origin, and I'm at an angle of 180 degrees, or pi radians. Let's see, 4, -8 is down here, so over 4 down 8. So I'm in quadrant 4. I can do Pythagorean theorem. So let's see, 16 plus 64 is what, 80? So if you want to just leave it as the square root of 80, that's fine. What is 80 as a reduced radical? So let's see, 80 divides by 16. So it would be 4 root 5 if you wanted to get fancy. And then I'm going to do the tan inverse of y divided by x. Y divided by x is 2. And I'm in degree mode on my calculator. So second, tan inverse of 2, 63 about degrees. So I'm going to call it negative 63 degrees because I've gone negative 63 from the origin. You could also think of it as how far did you go in this direction? So 360 minus 63, you could say 297 positive. Graphing polar graphs without using technology. So whenever it's an angle and it's equal to an angle, you could just, identify and graph each equation. So I'm going to also convert the equation into rectangular form, even though it doesn't ask me to. So let's find where 45 degrees is here, right? So if I was going to graph this, it's just a line through the origin. So the line is actually y equals x because it's a 45-degree angle. If you wanted to go conversion steps, tangent of an angle is the same as y divided by x. The tangent of 45, or pi over 4, is 1. Multiply x to the other side, and you have a line through the origin with a slope of 1. R times the sine of an angle is the same as writing y equals. So this would just be a horizontal line at 2. So graphing that on polar graph paper is not too bad because you could just go 2 units away from the origin with your horizontal line. So if you notice the difference between B, when I gave you r sine of theta, and C, when I said r equals 4 sine of theta, I can't just replace this with a y. So the strategy I showed you in class was to actually multiply both sides of the equation by r. So r squared equals 4, r sine of theta is y, and r squared is just x squared plus y squared. So x squared plus y squared equals 4y. I'm going to actually figure out what kind of a circle or ellipse this is by subtracting 4y to the other side. So x squared plus y squared minus 4y right now equals 0. Add 4 to both sides to complete the square. So x squared plus y minus 2 squared equals 4. So this is a circle with a center at 0, 2 and a radius of 2, right? But it's a circle, so I couldn't necessarily identify it at this step, but by transforming it into rectangular form, I know things about it now. And on this equation, kind of the same steps, you're going to multiply both sides by r. R squared equals negative 2r cosine theta. get rid of those. So x squared plus y squared equals negative 2x. Add 2x this time to the other side. X squared plus 2x plus y squared equals 0. Add 1 to complete the square. X plus 1 squared plus y squared equals 1 this time. So this is a circle. It has a center at negative 1, 0, and an R value of 1. All right, so this is just practicing using technology for this last question. So you're going to make sure that you're in mode polar. So polar mode, degrees or radians should work. Go to y equals. I'm going to do 8 sine of 5 theta and then hit zoom 6. So that was kind of like a flower or star. So just sketch a graph so it kind of looks like this. Kind of like that. It went out 8, right? So it'd be nice to mark that's 8 and it's at the origin. And then what about, let's see. So it's 1 divided by 2 pi. So I want to make sure that I'm showing that the, actually I want to do 1 divided by parentheses. 2 pi is in the denominator times theta, zoom 6. So it should, this is supposed to be a spiral. So I may need to change my window, and I'm going to change this actually to radian mode so that my window, instead of being like 0 to 360 degrees, I want a bunch of revolutions. 2 pi is just 6 radians, right? So if I did like 24, I'd be getting about 4 revolutions. Let's do a small step. So let's do it like every half of a radian maybe, or every 0.1 of a radian. And let's go out kind of far, like, I don't know if I'll go to 1,000 or not. And we'll go negative 1,000. I don't know, I'm just setting up my window to try to see more. Oh shoot, did it save that graph? I might have gone out too far with my 1,000. Try one more time. Let's go from negative 100 to 100. It's just supposed to be a little bit more of a spiral than what you're seeing. Well, that might be as good as I get. It's really far in, I guess. Let's go one more time. Negative 20. So this is just a little guess and check because I'm not sure exactly how big the graph is. I was hoping to see more of the spiral. There you go. So now you can see more of the spiral. I just had to get in far enough, but so this is just a spiral. If you did more revolutions, you'd get to see more of the spiral, but just playing around with the technology.